In this video, we will further explain how to establish the rejection region or why the rejection region is being established. So we have here the normal curve or the curve of the random variables. And so if we have the given alpha or the significance level, then that simply means that the significance level is the rejection region area or the area of the rejection region. So if our significance level alpha is equal to 0.5, then the significance level is 0.5 and the area rejection area is 0.5, and the rejection region, the p-value so if the p-value is less than the alpha, then we can say that our null hypothesis will be rejected. So if the null hypothesis will be rejected, then that means the alternative hypothesis will be accepted. Okay. So if the p-value is less than the alpha, then that means that the area, p-value area, lies somewhere here, and you can reject the null hypothesis. Now, there is what we call as the two-tailed test. So in the two-tailed test, you have the rejection region, but the rejection region is right and the leftmost part of the curve. And as you can observe, this area here is actually equal to the alpha over 2. And the leftmost is also equal to the alpha over 2. So in terms of p-value, still you will consider just like the value of the alpha. But this will be significant. This two-tailed test will be important when we are going to use the computed values of the test statistic to be used and compared to the critical test statistic to be used. To make it clearer, let us go to what we did in our example. So in our example, we have this curve. So we have shown in our example only one tail, such as this. But in actual sense, it should be a two-tail, since our null hypothesis HO is equal to, as stated, mu1 equal to mu2. And our alternative hypothesis states that our mean of 1 is not equal to mean of the second set of samples. So that means that if it is not equal, it could either be one set of samples could the mean of one of the mean of the set of samples could either be greater than or less than the other. That is why two-tailed test is most applicable. So in this case, we will just be using t of alpha over 2, and that's a plus sign for the upper bound, and negative t alpha over 2 for the lower bound. How will this affect our judgment of rejecting the null hypothesis? So this will be our base concept. So in order for the null hypothesis to be rejected, the computed t or the t sub o, should be less than the t alpha over 2, and that's a negative t alpha over 2, and it should be greater than the positive t alpha over 2. Why? So if that is our computed t is greater than the t alpha over 2, then the value of the computed t will lie somewhere here. So that means that it lies in the rejection region, so we reject the null hypothesis. On the other hand, if the t computed is less than the negative, and that's the lower bound, alpha over 2, so that's less than t alpha over 2, then it lies somewhere here, and it also lies in the rejection region. So this is one additional information of rejecting the null hypothesis when considering a two-tailed test. Thank you.